Welcome back friends. This is our fourth problem. Remove duplicates from sorted array 2. This is the label of this problem is medium. Let's open this. So what we have to do? We have to remove duplicates element from this particular sorted array. So we have given an integer num sorted non-decreasing order. It means in ascending order. Remove some duplicate in place such that each unique element appears at most twice. So two times we have to show duplicate element if the relative order of the elements should be kept the same. Since it is impossible to change the length of the array in some languages, you must instead have the result to be placed in first part of the array nums. More formally, if there are k elements after removing the duplicates, the first k elements of num should be hold the final result. It does not matter what you leave beyond the first k elements. Return k after placing the final result in the first k slots of nums. So here is our input triple one double two three. So our problem statement says we can repeat one element at twice, not more than that. So here if you see double one double two and 3 appears at 1. We need not to worry about the latter part of the array, just we need to return the length of this particular array. So it returns 5. Okay, so we have this array something like that. So this is our array 0, 1, 2, 3, 4 and 5. So what we have to do, the output should be 1, 1, 2, 2 and 3, and we need not to worry about the last element. So this will be our final output. So how we can solve this problem? So what we have to do, we have to prepare pair if we have more than two elements. If it is one, we need not to do anything, but if there are more than one element, then we have to put only, so put in it as twice only. We need not to put thrice and more than that. So how we can solve this particular problem? To solve this problem, we can use count. The count, what this count pointer will do, this point counter will count the length of the particular element. Okay, so count will start from first and then we increase if we found the element, same element. This is our first pointer, and then again we have to take one more pointer, let's say k is equal to 1, and now third pointer we will take from our for loop. So what we will do, we will start loop from I is equal to 0, I less than nums of length and I plus plus. So now what we have to do, so we will start from first position because the first element. Okay, the I also we will start from 1. Okay, I is equal to 1, I less than, something like that we have to write. So what we have to check, we have to check this element and this element are same or not. At this particular point of time, this I is representing this particular pointing this position. So how we compare with this? So we can write I minus 1. So here we can write if nums of I does not equals to nums of I minus 1. If both are not equals, then what we have to do? We have not equals, then we have to do count is equal to, let me write again it. I'm writing wrong condition. So let's start from here. I want to compare this particular ith position is 1 and I want to compare with its previous position. If both are same, then I have to increase this count. Okay, if both are same, then we have to increase the count. So the count here is 1. So here I will write if nums of I is equal to nums of I minus 1. In this case we have to increase our count to count plus plus. Otherwise in the else case we have to initialize count as 1. It means that this element came at first time. So this is our if and else part. Now we have to shift the value or put the value in nums. So based on which condition we have to write? We have to write like if I is, we have to write based on count. Count is less than or equal to 2. If it is less or equal to 2, then what we have to do? We have to put element at kth position and then we have to increment the k. Nums of k is equal to nums of I and then k plus plus. At later we have to return this k only. I think by this we will be able to solve our problem. Let's understand with this particular flow. Okay, initially let me remove this 1 1 1 2 2 3. Initially at ith position I is 1. This is our 0 1 2 3 4 and 5. Okay, at first position what we have this one coming into loop. If nums of 1 means here we are comparing 1 is equal to I minus 1 is equal to I0, that is 1. So this condition is true coming into inside this if block. Okay, count becomes 2 now. Count is equal to 2. Again, it came to this particular if block if count is less than or equals to 2. So we have count value is 2 now. So this condition is satisfied. Then what we have to do? We have to put k is equal to nums of I. So k is nothing but at first position. So kth first position is also this particular, it is pointing to this particular position. So what we did, nums of I is nothing but first position only. So we are putting first at first position. It doesn't change anything and it increments k to k plus plus. Now our k becomes 2. Again I is equal to, now our I increments to 2. I of 2, it means this location, it is comparing with this location and this location. Okay, so both are same. Again count increments to 3, this become 3. So what we have to do, it becomes 3 now. Now if count is less than is equal to 2, then we have to do this work, otherwise we need not to do this work. So we are skipping this part now. Again I becomes 3 now. Nums of 3, it means that this position, okay, 3 and second position is 1. Are they are matching? No, they are not matching. It means that 2 is equal to 1, that is wrong. Came to second part. Now it initialize count to 1 now. Now our count becomes 1 because this 2 appears at first time. Now our 2 is count becomes 1. Okay, already we have k at second position. So count is less than or equals to 2. This condition satisfied. Yes. So nums of k is nothing but 2. What we have to put? Nums of I. And in nums of I, it means nums of 3 we have this 2. So what would be our value in the new array? 1 1, and at this position we are shifting this particular element, so it will become 2 now by using this. Now we are incrementing k by 1, k plus plus. Now k becomes 3. Okay, again it will compare with our I will increase with 4. 1 I plus plus means I 4. So ith of 4 position we have to compare with this position and this position, third position. So both are same, so we will increase this count. Now count becomes 2. Okay, now count becomes 2. Again it came here and this condition is satisfied. We have k is 3 now. So at third position what we have to do, put this 2 here. Basically it won't change anything. Now coming again to this loop, it will become 5. Okay, nums of 5, which is 5 is equal to I minus 1. It means that this is 3. This will compare with 3 is equal to 2, which is incorrect. So this part will not work. This part will work. Count is equal to 1. Now our count becomes 1, and again it will again check count is less than is equal to 2. Yes, it is less than is equal to 2. And what we have in the k, we have k is previously we have increased the k in the previous iteration, it assigned here. Now k was incremented, so it was 4. Okay, now in this iteration what we have to put at fourth position, what we have to do, we are replacing with this particular position. So k is equal to 4, then fourth position we are assigning the 3. Now this array will becomes like this. Again it will check, but it won't match the previous, so it won't work like. So I think this will solve our problem. Let's get started with coding. So we have int count is equal to, so every pointer we will start from 1 only. Here also is equal to 1, and we will write for loop. This for loop will start from 1 only. I less than nums dot length and I plus plus. Now we have to compare whether I and I minus 1 both are same or not. Nums of I is equal to nums of n minus 1. If both are same, then we will increment this counter pointer, count plus plus. Otherwise if they are not matching, then what we have to do, we have to initialize count again as 1, and after this we have to write one more if condition to shift or to assign element into this array, so that the complexity will remain order of 1. We are not using extra array or something like that. We are leveraging the same array. Nums of I, if count is less than or equals to 2, then we have to put value at nums of k is equal to nums of I, and here we will increment this k element, k plus plus. Once we increment here, we have to return this k. Num of I is equal to nums of I minus 1. Okay, Both the test cases passed. Now let's run this, submit the solution. Okay, submitted. So in this case, we are using only one for loop. That's why the complexity of this particular application is order of n. Time complexity and space complexity is order of 1 because we are not using extra space. Thank you so much for watching.